Hey everyone, so I'm going to be doing part 2 of our logs or solving logs, and I apologize because the first video froze when we were doing this problem. F is very similar to E, so you can kind of see the general steps here. The only thing that's different is notice that on E I left it in logarithmic form, and the reason for that was because I could not reduce anything. On F, the one thing that was a little bit unique is that the top and the bottom, when we got to the bottom here, we had log 2 and log 2, and so those log 2's were able to cross off and leave me with just 1/2 as for a half. So something to kind of consider is that if you happen to have a logarithm with the same base and the same number, then you are able to cross those off, okay? So what we're going to do now is we are going to kind of summarize what you've just done on the back of the note page, so page 18, and then we're going to do some word problems as well, okay? So I'm going to have you guys pause this, but just explain the steps of solving an exponential equation with E, okay? So with a base of E. So if you happen to have a base of E on some of these problems, how would you solve an exponential equation? Or I'm sorry, exponential equation. So just to recap, if you want to pause and try it first, okay? So first step is we're going to get rid of our coefficients. And we usually do division there, right? Then what we're going to do is we're going to ln or log both sides. Okay. Now, when we log both sides, what happens is if we happen to have a base of E, then it's going to give us 1, and it's going to we're going to be able to use log properties essentially to solve. So use log properties to get rid of exponent. And then lastly, you're going to solve for x, or solve for variable. Okay, so kind of the same steps. The only difference is because we have a base of E instead of a base of like 10 or something like that, we're going to use ln instead of our natural log. Okay, so what we're going to be doing is we're going to be solving these types of problems, and then that's going to be it for this note page. So these problems are problems that you haven't seen before, so bear with me. This is really going to be just kind of like a note page that we're going to kind of walk through each one of these and see how we're able to use logarithms to help us solve problems that maybe we initially didn't think were log problems as well, okay? So it says your new car is depreciating at 10% per year. You paid $15,000 for it. How long before it is worth half of its value? So a couple of things that you need to understand is that because we're dealing with depreciation, we're dealing with an exponential function here. Now, I'm not sure if you remember, but we have this formula where it's principal times 1, and usually it's plus the rate. Because we're depreciating, it's going to be minus the rate to the power of time. So when we were dealing with our exponential unit, we talked about investing. And in investing, we would do 1 plus r because we're actually gaining value over time. Because we're depreciating here, what that means is that we're actually losing value over time. And so that's why we're going to have a minus sign here, okay? So our principal amount is the 15,000 here. Okay, so P is equal to 15,000. We know that our R is equal to 10%. And remember, we always have to change that into a decimal, so 0.10. And our time, we actually have no idea what our time is. That's what we're trying to figure out. But we do know that we want to know what's worth half of its value. So half of 15,000 is going to equal 7,500. Okay, so we want to know when is it going to equal 7,500. So we can create an equation for this. So we have our principal times 1 minus our rate to the power of t, because we don't know our time, is going to give us 7,500. Now what's going to happen is we're going to use the same steps that we did on our last 2 letters of the front side of the page here. Okay, the only thing is that we're going to simplify what's inside our parentheses first before we get rid of the 15,000. So we want to get rid of our coefficients, which is kind of our step that we did before, by dividing. Okay, and then now what we can do is we can use logarithms to solve. Now, if you don't happen to have a calculator to use logarithms to solve to get the approximate value, what you can always do is you can do guess and check. So you can do 0.9 to what power will give me 0.5. And so there's always that option. If you don't have the ability to do logs, you can use logs. So you can use estimating. And I apologize too because I'm definitely running out of room here, as you can see. And so now I can use the properties of logs to bring t in the front. And then to get rid of log 0.9, I'm going to divide both sides by that. And so we can say that in 6.58 years, the car will be worth half its value. So you can see that this is kind of more of a real world problem that we're solving, but we're using logarithms to help us approximate the answer. So it is important when you are purchasing a vehicle, you do want to see its depreciation rate, because usually within the first 5 years of its depreciation, that's where it depreciates the most. And so it is kind of important to kind of note that, okay? So what I'm going to do now is, because I have so little space here, I'm going to go ahead and just pause the video, and I'm going to give you the answer for the H, and so that you can go ahead and try this on your own and see how you do. The one thing I want you to be careful on is remember that this is saying that it's worth a third of its value, so you need to find a third of 36,000 and not a half. So we multiplied by a half here. On this one, you'd multiply by a third, okay? So go ahead, try letter H, same premise as what we're doing before, and see if you get the same answer as me. All right, so for the answer, we should have gotten that the time was equal to 8.6. Okay, so it's going to be worth a third of its value in 8.6 years. Okay. And if you want me to go over this when we're in class, we can also do this as well. Just on this specific note page, I'm not going to write all of the steps for this one, okay? All right, so I and J, again, are very, very similar to each other. I'm going to show you two different methods that you can do to solve both of these. Again, feel free to use either one, whatever you feel most comfortable with. So one option that you can do is you can change these to be both exponents. What I mean by that is that 8 is actually equivalent to 2 to the third power. Okay, so one option is I can convert this, so x to minus 2 is going to be equal to 2 to the third. And by doing this, you'll notice that we have the same bases here. Okay, so when we have the same base, what that means is that we can just drop those bases off, and we can set it to the exponents equal to each other. So x minus 2 is equal to 3. And if you do that, you can just add 2, and you get x is equal to 5. So that's option number one. If you don't want to deal with logs, you want to just deal with what problem you have here, is you can just convert the number equal to an exponent and then set the exponents equal to each other as long as they're the same base, and then solve. Now, sometimes that's not going to always work. Like, so for instance, if this was equal to 9, I wouldn't be able to do this, and you'd have to use logarithms. So I'm going to show you how you would use logarithms here if you were not able to do what I just did. Now, on J, you can do the exponents because 6 to the second power is also going to be the same as this, but I wanted to show you the steps for the logs. So what you would do is you would log both sides. Okay, and then you would use the property of logs to bring the x plus 1 in the front. Then you would divide both sides by log 6. And you would have to use a calculator here. So if you took log 36 divided by log 6, you would end up getting 2. And then you'd minus 1 to both sides, and you get x is equal to 1. Okay, so the one thing that you have to remember about using the second method is you do need a calculator for it. This one, I didn't need a calculator at all, so it's really up to you on what you want to do, which method. I personally like the method of using exponents, so whenever possible, I use the method of exponents, but if it's not possible, then logarithms is a great solution as an alternate. So that's going to conclude this note page. I hope that you gained a little bit of better understanding. We will cover a lot of these concepts in class though, so just make sure that your note page is complete and that you have a general idea as to what the steps were that we completed, and then I will talk to you guys later in class.